Welcome back, students. Today we are going to continue working with the quadratic formula. So just as a refresher, do you have the quadratic formula memorized? If not, that's okay, but I would like it if you do. Okay, it's always a good formula to have, one of the most important formulas that we have in math. So that quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, so the discriminant is going to be part of that quadratic formula. And notice it tells us that the discriminant is b squared minus 4ac. So it is the part of the quadratic formula that is underneath the radical. All right, so it doesn't actually include the radical. It is the part that is underneath the radical. So notice to figure out what b squared minus 4ac, notice to figure out what the discriminant is, you still need to get your quadratic into standard form. And you need to identify your a, which is the coefficient of your x squared term, your quadratic term, your b, which is your coefficient of your linear term, and your c, which is your constant. And what the discriminant does is, without actually solving the entire problem or without actually graphing the problem, if you know what the discriminant is, you know the nature of your roots. So you know that if you hadn't graphed it, if that graph would cross that x-axis. You know that if you hadn't even graphed it, that graph might be a nice whole number or a rational number, or if it's going to be decimal answers and so on. All right, so what we're going to do is we're going to take a look at 4 examples. Okay, these are coming from the 4 examples that were on our quadratic formula notes. And we are going to pretend like we hadn't worked this all the way out. Okay, so this first example is x squared minus 8x. Move the 33 over to get a minus 33 equals 0. Identify a to be 1, your b is negative 8, and your c is negative 33. Plug it in, and what we care about is just the b squared minus 4ac. So b squared, so that'd be negative 8 squared minus 4 times a times c. Yes, use a Desmos, that is fine. Use a calculator to simplify. This simplifies to 196. All right, so that's what we care about right here. So had we not actually gone through and used the quadratic formula to figure out what the solutions are, what's 196 going to tell us? Well, it's going to tell us a lot. First of all, 196, that is a positive number. So because this is a positive number, that means we're going to have real answers. We're going to have real solutions. Why are we going to have real solutions? Well, because complex comes from having a negative underneath the radical, because the square root of negative 1 is I. All right, so complex numbers have that imaginary number I in them, which only comes from a negative underneath the radical. So that means that if you have a positive discriminant or if you have a 0 discriminant, you are always going to have real roots. What else this is going to tell us is the fact that 196 is a perfect square. If you need to, you can go to Desmos and take the square root of 196. And if it gives you an integer value, so a whole number, then it's a perfect square. 14 times 14 is what gives us 196. So yes, it is a perfect square. And what that's going to tell us is, because that gives us a perfect square, the radical goes away, which is telling us that we are going to have rational roots, which the word rational, if you don't know it yet, memorize it. Rational means ratio, which means fraction. You can write a rational number as a fraction. What else this is telling us is, because 196 is a number that is not 0, it means that when you add or when you subtract, because it's not 0, it means that those are 2 different numbers, which means that we are going to have 2 roots. Because these are real roots and we have 2 of them, that means we are going to have 2 x-intercepts. All right, so we can verify this by looking at what the graph is. If we look at what the graph of this is, typing it into Desmos, we see our parabola, we see the x-axis, we see the graph cross the x-axis in 2 places. So because it crosses the x-axis, it means that those were real roots. Because it's crossing in 2 places, it means that we have 2 real roots. And then if we actually click on what those roots are, these are negative 3 and 11, which are both rational numbers. Negative 3 can be written as a fraction as negative 3 over 1, and 11 can be written as a fraction because it can be written as 11 over 1. So these are both real rational roots, which means we have real rational x-intercepts. All right, let's take a look at another one. So this next one, the discriminant, so jump ahead to what's underneath the radical when it's been simplified, we get 0. So for the second one, we get a discriminant of 0. So 0 Is the discriminant a perfect square? Well, yes, 0 is a perfect square. 0 times 0 is 0. How many roots are we going to have? Well, if we add or subtract 0, okay, if you take any number you want, any number at all, okay, add 0. Okay, go back to that number that you picked. Subtract 0. You still get the same number, right? Adding or subtracting 0 gives you the same thing, which means that we're only going to have one root. Okay. 0 is not a negative number, which means we're going to have a real solution. 0 is a perfect square, which means that we're going to have a rational solution. And because it's real, that means we're going to have the same number of roots that we had, which is going to be one x-intercept. All right, so if we take a look at the graph of this one, okay, we're going to verify what we just had, which, looking at the graph crosses the x-axis. It actually just touches in one place. The vertex is on the x-axis, which means it's a double root. All right, so we have one unique root, and 17 is a rational number. All right, so I was able to tell all of that by knowing that my discriminant was 0. All right, next example, the discriminant is 28. All right, so coming here, the discriminant is 28, which 28 is a positive number. 28 is not a perfect square. What that tells me, number of roots that I'm going to have, 28 is a number other than 0, which means I'm going to have 2 roots. 28 is a positive number, which means I'm going to have real roots. Okay. And since 28 is not a perfect square, it means I'm going to have irrational roots. When I try to break down the square root of 28 later, okay, which I see here where I actually did that, when I break down the square root of 28, okay, I can rewrite this as the square root of 4 times the square root of 7. Square root of 4 is 2 times the square root of 7. Right here, I get 2 square root of 7. This radical stays, which means that the radical sign, I can't write that as a fraction. So that means that these roots are classified as irrational. But they are real, which means it does cross the x-axis in 2 places. All right, my last possibility is here I get a discriminant of negative 48. So I haven't looked at the case of a negative yet. All right, so if I come up with a case that I have a negative discriminant, no, obviously it cannot be a perfect square. How many am I going to have? Well, complex roots always come in pairs, so I'm going to have 2. And I already said that these are going to be complex because I know I'm taking the square root of a negative. I do not ever classify complex roots as rational or irrational. That's only a subclassification of real roots, so I'm not going to have anything here. And then how many roots am I going to have? Or I already said that here. How many x-intercepts am I going to have? That's going to be 0. That's probably the trickiest box. Even though I put a 2 here, and every time I put my answer here, it always matched my number of x-intercepts. Well, that's because that matches when you have real roots. Anytime you have complex roots, it means that your graph, your parabola, is never crossing that x-axis. All right, so here's that case. I'm going to zoom out. Here's my parabola. Notice it never crosses that x-axis, which means I don't have any x-intercepts. I do, however, have solutions. It's just that those solutions are going to be complex solutions. And here, using the quadratic formula, is what those complex solutions were. All right, I guess I never looked at the graph for number 3. Here's what the graph for number 3 looked like when I had 2 irrational roots, 2 irrational real roots. I do have 2 x-intercepts, but when I click on them, notice that I have those decimals. All right, those can't be written as a nice fraction. All right, so this notes page is attached on Google Classroom. If you get stuck, you can come back to this video or you can read through it, and it tells you exactly what you need to do to fill out each of those boxes. Here's what your homework is going to look like, which is also attached to Google Classroom. There will be two tabs that you need to have open, probably 3 because the graphing calculator is always helpful as well. But you're going to have the tab open that actually gives you what the equations are. As for the rest of this, it's going to be filled out on the Google form. So please make sure that you include, first of all, make sure that you are on your Chromebook or that you are at least opening up this Google form by using your school email address. And then please tell me which block you have Algebra 2. And then you're going to go through and you're going to answer these questions for the equations that are provided on the worksheet. So the very first one is 4x squared minus 12x plus 9 equals 0. So this is already in standard form. So I know my A, I identify my B, and my C. I'm trying to come up with the value of the discriminant, which is b squared minus 4ac. All right, so when I plug this in, I'm going to have b, which is negative 12, squared minus 4 times a, which is 4, times c, which is 9. All right, so I can use Desmos for this. And what I'm going to have is parentheses. Please make sure that you include those because Desmos will follow order of operations. So negative 12 squared minus 4 times a times c. All right, and that tells me what my discriminant is. So in this case, it's going to be 0. All right, so what I'm going to do, my value of my discriminant is 0, so I'm going to type that in, which is 0. It's not positive, nor is it negative. It's 0. 0 is a perfect square. Yes, it is. 0 times 0 is 0. Because it is 0, when I add 0 or when I subtract 0, I'm going to get the same number, which means I'm going to have 1 root. That root, 0, is not negative, which means that it's going to be a real root. And that means also, since it's a perfect square, it's going to be a rational root. So because it's real, that means I can go back to how many roots I have, which is 1, which tells me how many x-intercepts I have. All right, so I can get all of that by using the discriminant. I'm going to come over here and I'm going to verify. All right, so my question was 4x squared minus 12x plus 9. That was my quadratic, so I'm going to go ahead and have that graphed. Here's that parabola. What I'm focusing in on is the root, which means my x-intercepts. So in this case, it crosses the x-axis in one place. All right, there it is, 1.5. I know it's a decimal, but 1.5 can be written as a fraction. Okay, how can that be written as a fraction? Well, that would be 3 over 2. So what is my solution, since there's only one of them? I'm going to put it in a solution set. Please do not use any spaces. So I'm going to type in my brace. Okay, I'm going to type in my left brace. Whoops, and then I'm going to type in that fraction, 3 over 2, and then I'm going to close it. All right, and then I'm going to click next, and then I can do the next one. All right, so I'm going to let you do question number 2 on your own. But again, it's the same thing where I go through, try to figure all of this out. Please make sure that in question number 2, I'll give you a little hint that there should be 2 solutions, 2 exact solutions. Because they are exact solutions and they are nice rational solutions as well, you can just use your graphing calculator to get those. You won't need to show any work for that. But please, when you're typing them in, put braces around them. I'll go ahead and tell you what they are. They are -1 and 0. All right, so please make sure that you can get those, that you can verify those. Do not include any spaces when you type those in. All right, for question number 3, I do want to do this one with you. So question number 3, that is right here. Question number 3, we have our A, we have our B, we have our C. Okay, so our A is 1, our B is -12, and our C is 72. So plugging this into the discriminant formula, that will be B squared, so -12 squared, minus 4 times A times C. All right, so typing this into Desmos, I have -12 squared minus 4 times A times C, which was 72. Which gives me -144. All right, so -144. Whoops, I don't need that. I'm typing this into my Google form. All right, so the value of the discriminant is -144. Again, please no spaces. That discriminant is negative. Okay, 144 is a perfect square, but because it's that negative, I don't want to include that negative. I'm not going to have it be a number times itself that gives me that -144. So no, that is not going to be a perfect square. How many roots am I going to have? Well, maybe I need to answer this question next. Those roots, since it was a negative under the radical, mean it's going to be complex, and complex roots always come in pairs. So that means I'm going to have 2 of them. Okay, because I'm going to add and I'm going to subtract something other than 0, which means that I'm going to have 2 different answers. Because those are complex roots, I do not classify those as rational or irrational. So I'm going to click on does not apply. How many x-intercepts do I have? This is a tricky one. Even though I have 2 roots, because those are complex roots, it means I have 0 x-intercepts. All right, so what am I going to do over here? I'm going to go ahead and graph that, which I have it already all typed in. I'm going to go ahead and just click on my graph, and now I'm going to zoom out and try to find it. My constant was 72, so that should be a big indicator that I'm up here at 72 for my x-intercept. Yep, there's my x-intercept at 72. Here's my graph, my parabola, and as you can see, nowhere near crossing the x-axis, which just verifies that I should be right on how I answered that because I don't have any x-intercepts, which means that while there are still two solutions, those are going to be complex solutions. So there are going to be two of them because complex solutions always come in pairs. All right, so now my final step is to figure out what are the solutions. All right, so this I will need to show a little bit of work, and this is what you're just going to put on your own sheet of paper. Question number 1, question number 2, I don't need to show any work because I can get those exact solutions from that graphing calculator because they are nice rational roots, which means that I can just use the graphing calculator to tell me what those x-intercepts or what those solutions are. But if you ever get complex roots, okay, so if you ever have that negative discriminant or if you have irrational roots, you have to show work because you need to figure out what are those exact solutions, and the graphing calculator will only round it for you. All right, so what I'm going to do is I'm going to continue on using what I have here. So pardon me, I'm going to just write over top of these lines. But I already figured out that my discriminants, what was it? Negative 144. All right, so using the quadratic formula, I have positive or negative square root of negative 144. And then now I just need to put the other part of the quadratic on here to use the quadratic formula to solve. So it is opposite b. So b was negative 12. So opposite b would be positive 12. And then plus or minus the square root of negative 144. I already have that. And then all over 2 times a. So my a is 1. So 2 times 1 is 2. All right, so here it is. Here's my exact solutions. I just need to make this look better. I need to simplify this. All right, so simplifying all of this, I'm going to have 12 plus or minus. I think I'm going to work with the radical first. So the square root of 144 could be rewritten as the square root of negative 1 times the square root of 144. So square root of negative 1 is I. Square root of 144 is 12. So put that in order. That'll be 12i all over 2. Now we break our real from the imaginary. So 12 over 2 plus or minus 12i over 2. And this is going to give me 12 divided by 2 is 6 plus or minus 12i divided by 2 is going to give me 6i. So here would be my exact solutions. All right, 2 of them. Okay, 6 plus 6i and 6 minus 6i. So please make sure that when you type these in, you do not use any spaces, but you are including your solution set. So I'm going to do my left brace, and then I'm going to do 6 minus 6i, comma, 6 plus 6i, and then close it. All right, so no spaces. Always do the smaller followed by the larger value. All right, and then I'm going to click next, and that's going to be the end of what I do to help you through this. All right, so if you're finished with this and you can't finish the rest of it now, please make sure that you click next till you get to the very end. This is kind of annoying, but it is what you need to do anytime you work with the Google form, is go to the very end so then you can submit it. And that's the only way that your answers that you already have typed in are going to save. So then once your response has been recorded, you can go to view your score. Okay, that's viewing your accuracy. And notice that right now I have 17 of 72 questions correct. All right, so when I come here, I can look to see how I did. Equation 1, I got 8 of 8 points right. Equation 2, I got 1 of 8 because I went and told you how I wanted you to type in those solutions. Equation 3, I got 8 of 8. All right, so then now you'll need to do the rest of equation 2, all of equation 4, 5, 6, 7, and then 8 and 9. Okay, notice that for equation 4, I don't make you type in the exact solution. Same with equation 5. I don't make you type in the exact solution. Same with equation 6. But then starting with equation number 7, I start giving you multiple choice. All right, so I hope that video helps. This is what you need to do as you are working with the discriminant. Homework number 28.